before I start, I would like to thank the organizers for inviting me to meet you all virtually. So I'd like to thank the HOD and other authorities of the institute. So I'll be discussing about the AI in cybersecurity. So as AI, how much it supports for the cybersecurity, as well as what are the security challenges that AI faces. So before I move on to the discussions, let me want to ask you a question. Maybe I will answer also. Let's consider that people these days more focus on ML or AI and very less focus on cyber security. Or I may be wrong also, but let's consider this is the scenario. So my question is that we have to find some application where the following cannot be applied. For an example, we can say that we have to give some application which is having the smartness, because once there will be a digital communication, then only we can think about our need for a cyber security. Okay, so is it possible for us to tell any such application where we cannot apply cyber security, or cyber security is not required? If we see in overall, we cannot say any such application, because whenever we are going to connect multiple devices together, then we need cyber security. Even if we are going to have the standalone device, we need cyber security. The reason is sometimes we will bring the pen drive or external disk and connect. So from that also the malwares can spread. So next question is again the same question, whether can we find any application where AI or ML cannot be applied? So the artificial intelligence cannot be applied to any of the applications. So it will be very complex, because these days we say that all the applications are we can apply AI in all applications. But one thing we should remember, the AI or ML is based on the training. So based on the pattern, we give the training, then it learns and accordingly it behaves. If the pattern is not going to have the, let's say, sequence, or we can say there is no pattern present. If it is random, if the data is random, let's say if the data is not having the proper pattern, but it is having the randomness, so then the AI and ML cannot work. So as of now we can say, but later not sure what is going to happen. Even the human cannot solve that. For example, if I ask, in cricket we see they put toss, so nobody can predict more than 50% accuracy that what will be the outcome, whether it will be the head or tail. And if our data set is like that, then AI cannot work. So we can say that we have an application which is based on the randomness, that's the cryptography. And for the cryptography, we cannot apply the machine learning algorithms. So why I want to say this is, it's not like only we need machine learning or AI, we have to focus on the cyber security also. Yes, we use AI or ML for the cyber security, but at the same time, ML is also having the security weakness. So we need to focus on the cyber security of that also. So this is the generic ML system. Maybe you people know about this. Let's say that we take the data set from various sources, maybe like we download from some repository, and then we do the assembly. For example, here in this diagram, it shows that the data collected from the raw world, and very minimal researchers does this. They collect data from the real world directly. Otherwise, what happened? There will be the data set, as I said, it will be there in the various repositories. So from that repository, we can say that the assembly has been done, like after pre-processing the data. So we see that there is a raw data that is collected from the real world through the sensors or other devices, and then we keep the data after pre-processing, and those data are taken and classified as like training data set, validation, and the test data set. So now using this data set, we will be modeling our algorithms, and the algorithm will be learning. So here we are talking about modeling the algorithms. That means the model will be learning, and we will be evaluating the model. So whether the prediction is accurate or not, accordingly we will be fine tuning the uh, input parameters. That means the features. So after that, once the model is ready, so we put it into the real time, that is the real world application. So where we say that as the inference algorithm. So for that inference algorithm, the data directly comes from the real world, and the algorithm works and predict the output. This is what the generic ML system is. So this is what used by all of us in most of the cases. For example, when we do research, we focus on the second point. That means just we download the data, and then 3, 4, 5, and 6. So these four modules only we maximum use. So when it comes to the real world system, so then only we go for all these 9 modules. So I will talk about the issues on these modules little later, but let's see that how ML can help the cybersecurity. So now ML is massively used in the cybersecurity implementation. For example, we have the intrusion detection system and the intrusion prevention system. Earlier, what happened, we used to have the signature based detection. So means like we will be having the data set, and based on the data set, that means let's say we have a set of patterns, and whenever any network traffic comes, the traffic will be mapped against those patterns. If the pattern is matching, that means there is a malware present, otherwise it is not present. So what happened in this case is, if the malware is present in our signature database or the pattern database, and now the pattern, the network traffic that is coming from the outside world are rising within the organization also, so it will be mapped against those database, and it sees that there is a matching, so then it immediately alerts or prevent that particular traffic. So in that way it works. So here the accuracy is 100%. If it is available, it say it is available, otherwise it says not available. So we can say the false positive and the false negative will be 0 in this case. But the problem with the signature based models are that let's say that we have a signature database, and there is a malware that is coming, new malware that is coming, but that pattern is not exist in our signature database. So in that case, it is not possible for our intrusion detection system or prevention system to identify. So because of that reason, we go for the anomaly based detection. So where they look at the outlier. So there the ML is getting used, or the AI is getting used to identify. So these days it is getting used in IDS, IPS, antivirus, and even in firewall also. So they are not completely trusting on the rule based. So they are going for the anomaly based also. And for the malware analysis also, and then to identify the phishing emails, or let's say that if there is any malicious URL. So in for all these things, we are using ML models or AI models these days, so that our cybersecurity mechanism will be robust against the new attacks that are coming. Because earlier days, the attackers were not having or using the model which has the intelligence. So now what happened, let's say when we are going to develop a model that will be having the intelligence, so that model, that intelligence model is available for all, so it's public. So the attacker is also using the same intelligence, and then they are making the malwares. So in such case, if you are going for rule based, then we cannot detect it. So that's why ML based models are required these days. So what ML can do to identify, so in the generic overview I am giving. So what it can do is that it can analyze, for example, the intrusion detection system. So the packets are coming, the network traffic is there from the outside world to our organization. It can analyze each and every packet, or let's say that within the individual device also, standalone device, there are activities that are happening by the user as well as the inbuilt, or we can say that automated processes that are running on our machine. So what ML can do, it can analyze all the behaviors very efficiently. So means it can find out the pattern, so how the process is going on, and it identifies if any sort of abnormality is present, because it has the pattern. And once it finds that there is an abnormality, that means there is an irregularity in the processes, or it may be irregularity in the network, which is, we can say, as the outlier. Once it finds, then it will alert that this is suspicious, and it may alert or it may block. But most of the cases, what the organization does, instead of blocking, they go for alerting the user and keeping it as quarantine instead of completely blocking or deleting it immediately. The reason is there is a possibility of the false positive and the false negative. And why, as I said, the ML is required, because attackers are also getting intelligent. So we cannot say that only the protection force implements the intelligence, attackers are also implementing. So these days, what happened, the malwares are not like as it is. That means it won't be directly visible by when we look at the code that it contains some malware script. So it will be hiding or it will be changing frequently. So in that case, if we are going for the rule based or the signature based model, it will not work. That's why the ML is required to solve it. But when we go for the ML, as I said, the major problem is on the accuracy. So we will be getting the false positive and the false negative. In the organizations, mostly they don't like false positive. The reason is, let's say I design the model and I give it to the organization where they need 24 hours service, and because of some false positive in my model, so they have to shut down the service. So when they are going to shut down the service, it is not actually that attack is not present or the malware is not present, but my model is predicting that the malware is present. So in that case, what's going to happen, the organization has to shut down the service to analyze that. So when they are going to shut down, so we can understand that how much they will be losing in their business. So in case, let's say their business is going to have huge income for every period of time, and if we are going, if because of my model we say that you shut down the service for a period of time, that means they are going to lose massive. So that's why they don't like. So since the ML is having the false positive and false negative, before applying it, we have to analyze more carefully, and we have to ensure that it gives the better accuracy. We should not say that 50% accuracy is sufficient. 50% can be done with any random models. So we have to ensure that it gives the better accuracy. See, one is like, as for research, we get the good accuracy, that's different. But we have to check in the real time also. The reason why we have to check in real time, in case of the paper, we take the same data set and classify into training and testing. So there we will get better accuracy. But in real time, it is going to face something different. So the data may be of similar nature, but it is coming without any pre-processing. And we are also not sure that the data that is coming will be exactly same as what was trained. So there we get the chance for the false positive and the false negative. And sometimes what happened, because of the privacy issue also, we have to we will be getting the false positive and false negative. So that I discuss in some time. And what we do at our lab with ML, so we do various things. So the first is like we identify the operating system version. So what is our requirement? Like we have a target machine. So we will not be touching the target machine. Let's assume we don't have the physical access to the target machine, but we can send the network packets. So we can send, for example, HTTP request or ping request. So like that, we can send the network request and we get response for that. So from that, we want to predict that what would be the operating system that is getting used at the target machine. So for that, it's like there are very, we can say the straightforward method. With the help of ICMP TTL, we can predict the operating system version, but there is no guarantee that it will give the accurate result, because sometimes the administrator may change the TTL, or the same TTL is with multiple operating systems, so we don't get the accuracy. So we apply the machine learning model after extracting various features, and then we try to predict. So not only we are going to predict like it is Windows machine or it is Ubuntu, we are going to predict we are predicting the version also. For example, if it is Ubuntu, then whether it is 16.04 or it is 24.04, that also we predict. Next, we identify the malwares with the help of the ML. But in this case, we are not only depending on the ML model. So we are doing various analysis, including the static and the dynamic analysis, to identify whether any malware is present in the coming files, or it may be the network traffic. We also analyze the APK files. So what we do is we do the static analysis of the APK file, which is the mobile application files. So we take that and see whether is there any vulnerability in that. For example, we want to check is the password hard coded, or let's say the key is hard coded. So these and all we are finding with using the ML. So you may ask the question why we need to let's say go for ML to find such pattern which are common. So what I can do is I will search if the word password is present. That means I can say that the password is hard coded, but actually that's not the case. So what our experience is, we were analyzing one of the applications and we found that there is no password present, hard coded password, but the tool was giving the output as the password present. So then we realized we should not go for the static method. We have to go for the ML based model to identify that. Next is like we also do or apply the machine learning model to scan for the web service vulnerabilities. So there are tools like Nuclei. So that contains various rules. So using that, we can check whether the web application is hardened or not. That means whether any security vulnerability present in the web service or not. But there are so many rules. So if we have n number of rules, it's very complex to perform that testing. So we have to try all the testing, and then finally we will get the result with what are vulnerability. But the rules are massive. So what we have done is we apply the ML model and see that what are the rules required and what are not required. Because if there are rules that are having the dependencies, then we simply skip that. So for that also we use the machine learning model. So like this, we can apply the machine learning or AI in various requirements of the cyber security. However, the issue is on the false positive and the false negative. So we also used LLMs, because these days everybody talks about the LLM. So what we have done is we asked the different LLMs like Grok, ChatGPT, DeepSeek, Claude, and Gemini. So we wrote a prompt asking these LLMs to generate a web application program. So the program is the program should contain the code for login page and then the login validation page. So only these two things we were asking, and also we asked the LLMs that it should follow the standard cybersecurity model in the code. So we asked the different LLM models and it produced the outputs. So after producing, we have taken the security requirements for those two pages. So we have prepared the list of security requirements. It's not that completely we are the one discovered that. We took from various sources. These are the requirements that should be fulfilled in these two pages. That means the two web pages. And then we check whether the LLM produced code is satisfying that or not, or providing that security requirement or not. We found that in case of the authentication security, so there are total 11 requirements. Out of 11, Grok has fulfilled 3. So the remaining, we can see that 1, 2. Even in case of DeepSeek and Claude, it was nothing was no security with respect to authentication security is provided. And in case of the input validation protection against injection attacks, so here also we can see that Claude is giving the better security. And in case of the session security, again the Gemini and the Grok is giving better. And like that, we have analyzed for all the broad categories of the security requirements. But what we found at the end is almost like the Grok is performing better or producing the secure code when compared to the other. So we can see here with respect to the risk. So we classified into 6 level of risk, like extreme risk, very high risk, medium, low, and very low risk. So for each and every category, we have analyzed what is the risk involved in each LLM produced code, and we can see at the level of extreme risk. That means including all these broader categories, because each category contains multiple requirements. For example, authentication security contains 11 requirements. Session security contains 8 requirements. So this figure is including all. So in case of the extreme risk, we can see that the Claude and DeepSeek is having the extreme risk. However, others are not having. So either Gemini, Grok, or GPT. But when it comes to very high risk, Grok is having almost it's like to 4, and then Gemini, it's like all the LLMs produced codes were having the high risk. So then when we come to the high risk, again all are having except Grok. So similarly, we can see for all the models, and as I said that it is like Grok is performing or producing the secure code, but still that also has the risk. So what our conclusion is, we should not just take the code from the LLM and directly use it. So before going to uh, apply into the real world application, we have to do the security analysis. The security analysis can be the automated tool, or it may be done manually also. Even we have tested with automated tool also. Even there also we found that there were risk involved in the code that's produced by the LLMs. Even our reviewers were saying that it might be possible that you are giving the prompt, that prompt is not clear to the LLM, so that's why it's giving the risk. But the issue is, and also they were saying that why not you give again and again and see that how secure it is producing. But our claim is like, if any person who is going to use the LLM and he is not having the idea about the cyber security, so then it's not possible for him to see that whether any vulnerability present or not and then go and check. So in that case, we can say that the LLM produced code is having the vulnerability and they will not go for the second time. So the again I repeat, the conclusion is it needs again the security test, then only we can apply in the real time implementation. So the problem with LLM with respect to security also, let's say, or with its performance, so there is a possibility of the prompt injection. So people will give different prompts. So normally what happens, sometimes we ask the LLM to give some data, it will say that as per the policy it's not allowed, because it says we cannot, for an example, the I ask the code for performing some attack. Then what happens? The LLM will say, no, this is violating the policy, so I will not give the code. But what happens if we give the prompt in different manner? So sometimes I say that I am the teacher, I want to teach, or if people may use different prompt. So then this will convince the LLM, and then we will get the injection can be performed. And there is a possibility of the data breach, because people are asking the questions. When asking the questions, they are copying and pasting also. For example, let's say what our students used to do, even sometimes what I will also do, if there is any error produced when I am going to running any code, so what I do, the error I copy and I search in Google. And when we are going to copy that error, there might be possibility that error will be including some sensitive data. In that case, what happens? When we put, the LLM will be taking it, and that will be produced to someone else also based on what prompt they are going to ask. So there is a possibility of the data breach. And another problem is, many times, like we can say that logical programming, it never says that I don't know the answer. It will give, if the answer is there, it will say as true, otherwise it will always say false, whether it knows or not. So that similarly, that LLM will also give some answer. Very rarely we can say that it will say that I don't have the answer. So that means it may give some misinformation to us. So these, like this, there are other problems are also involved with the LLM. But I cannot say that LLM is having the problem, we should not use it. So LLM is helping a lot, but there are issues involved in that also. And I was telling about the privacy issue earlier. So let's say that this particular table we have. So in this table, it contains non-sensitive data, sensitive data, as well as normally in table, the identity will also be there. But in this table, the identifier is removed because we want to ensure the privacy of the individual. So here the privacy means the data should not be mapped with any individual. So there should not be any tracking, and also there should not be any, we can say that, following up. So those are not required. Those should not be there. So for that reason only, here the identity is removed. But if you see what your record contains, so there will be an identifier, quasi identifier, and then the sensitive data. So we can say that this is the sensitive data, and the identifier is not present because it's removed here. And then we have the non-sensitive data, which we can say as the quasi identifier. So what the quasi identifier means, that just by taking the particular field, we cannot predict anything. That means we cannot map with any individual whether this particular row is of so and so person or not. That we cannot do. But by taking the quasi identifier and mapping with some other data which may be present in the social network or which we know personally, so then we can identify. For an example, let's say here, I know the person is living in this zip code, that is 13068, and his age is less than 35, or it is equal to 35, and also I know that he is American. So then we can directly map this entry with that particular guy. So in that way, the privacy will be leaked. So the privacy will be violated. So that's why what happens, they remove some of the fields. So when we are going to remove some of the fields and then give it to the ML for training, accordingly it will learn. So then what happens, there will be a trade-off. So when there will be a trade-off, that means the trade-off is between the accuracy and the privacy. If you want more privacy, then you will remove more data, then accuracy will be impacted. If you want more accuracy, then the privacy will be violated. So the disclosures, let's say in the privacy, there are disclosure happens. That disclosure can be the identity disclosure or attribute disclosure. So here the privacy issue comes because of the violation of the privacy. What attacker are going to get, they may get either the identity or they may get the particular attributes, whatever they want to know for any individual user. So to overcome that only, we minimize the data, whatever is visible in this. So, but when we are going to minimize and give it to the ML model, as I said, that the accuracy will be impacted. And earlier, what happened in the ML model, we will be having a single server or a server which is centralized, or set of servers that are centralized. We do the training, and the inference model will be applied in real time. So when we are going for that centralized one, there is a possibility of loss of data, leakage of privacy, and there is a possibility of single point of failure, because it's the single machine. Let's say if that is going to fail, or if the network connectivity is not there, then we cannot access that. And also, since it is single server, it is computationally load. So that's why Google has come up with a concept in 2017, that's the federated learning. So what it does, the main objective of this federated learning is to ensure the privacy. Let's say there are 10 hospitals, and all the 10 hospitals are having their own patient, and they want to train the model. So in the traditional method, what happened, we give the 10 hospitals gives the data to let's say the centralized server. There the model is trained, and then the trained model is given back to the hospitals. Then hospitals will be running that inference algorithm. Now the issue is, when these hospitals are going to give the data to the centralized server, there is a possibility that centralized server is compromised, that may be misusing the data. So that means the hospitals patients data is getting misused. So to overcome that, what we can do with the federated learning, the hospitals need not to send the data. So they will train the model using their data, that is their patient data, at their venue itself, or enterprise itself, or in their own premise itself. So similarly, all 10 hospitals will do. After that, the model will be sent to the centralized server. Now the centralized server can do averaging or summarizing, and the result will be given back to the hospitals. That is, the averaged or summarized model will be given back to the hospitals. So now the hospitals will be, without disclosing the patient data, they are getting the model which is trained based on massive number of data. So with that, they can further do any analysis or the identification of abnormalities in the patient's data. But the problem here is, so the federated learning is for that. So it brings the decentralization, and also it ensures the privacy. Now the problem is, when it is going to the centralized, the model is going, not the data is going. So there are attacks like model inversion attack, and also the membership attack. So using that, people will try to extract again the data. So that also need to be secure. So what's happening these days, people use the homomorphic encryption concept, means they take the model is encrypted and sent to the centralized server. Now like that, all the hospitals are sending the encrypted one. Now the centralized server will do the summarizing or averaging on the encrypted content and send it back. So now in that case, even the centralized server will not get any information. So we can see that the cryptography is getting used to secure the ML models. And the ML is also getting used in various applications. For example, like let's say we tell Alexa to open the door, and then Alexa will give the command to this lock, and then it get open or closed, whatever it may. But if we see the different attack vectors in this, so one is the voice recognition. So this is the first process that happens, and then it has to see whether the speaker is the right one or not, and then the command execution. So in all these, we can see that the first two, the ML models are involved to recognize that. If there is any attack that are possible, then the model will fail. This IoT application will fail. For an example, here we can see that this person who is lying in the bed, just speaking over phone or just talking to Alexa, saying that hello darkness, my old friend. That's what he said. But now what happened? Attacker come in between and they are inserting the message. It says that deactivate security camera and unlock front door. So that's going to the Alexa. But if somebody speaks like that, then this person will come to know that someone is giving the misinformation. But what attackers will do, they will make this message to be inserted. But when the people are going to hear, there are up to certain threshold only we can hear, otherwise we cannot hear. So that's the acoustic related value. So according to that, they will ensure the human will hear as hello darkness, my old friend. But when it goes to the Alexa, which can read even lower threshold also, that will get us deactivate security camera and unlock front door. So then what happened? Accordingly, the door will be open. So this concept was presented in one of the conferences in 2019 by an author. I forgot to mention the complete citation, but Schoner and their partners have did this work. And now let's come to the security risk at the machine learning model. So we have seen the generic ML system. So we see total 9 modules are there, collecting the raw data, data assembly and all. Now the first issue comes, the risk. So we collect the data from the real world using the sensors. So the issue is, what is the guarantee that the sensor is not misbehaving or the sensor is not compromised? See, because if we see the ML model, the data is more important, because accordingly the model get trained and it will behave. If the model is mistrained, then accordingly it will work. So the data is important, but the problem is the trustworthiness. We don't have the guarantee that whatever the data that we are collecting is correct or not. Similarly, we download the data set from various sources. What is the guarantee that they give the right data? Or when the people upload the data there, data set, what is the guarantee they upload the right data set? And next, when we are coming for pre-processing the data may be having some sensitive parameters, and while pre-processing, we will come to know what those parameters are. So the confidentiality is getting affected. That's the second risk. Then when we come into this model, because as I said, for ML, data is important, and based on the data only we give the training. So according to data, the model learns. If somebody poisons the data, then what's going to happen? According to that only the model learns. So it's very simple, like when we are growing, so what we see and how people are treating us, accordingly we will grow. If somebody inserts the poisonous things to us, so accordingly our mindset will also change. The same thing is here. And when it comes to the model, in some cases what happened, we will not be having the data set. So then we go for the transfer learning, because the application A and application B, let's say for application A we have the data set, but for application B we don't have the data set, but the application B is somewhat similar to application A, let's say. In this case, if the application A model we are going to take and use it in the application B, because it's similar and the no data set is available. If there is any attack in the model that is trained for application A, and we are going to apply the transfer learning and bringing it to application B, then what's happening? That attack is, whatever the Python training that happened, that is shifted to the application B also. And next is, in certain cases, what happened, the model will be keep on learning based on the new inputs, and attacker will try to manipulate the input so that they can make the model to behave in the opposite side. So instead of identifying the vulnerability, it will identify the non-vulnerabilities and leave the vulnerabilities. So like this, there are different risks that are involved in the ML model. So what I want to say, in ML model also there are security risks. So we have to apply the security model to ensure that no risk present in the ML models. So OWASP also has given top 10 security risk. So we can see that the first one is input manipulation. So there are input that is coming to the model. Let's say that the model is already trained, and now we applied that model in the real world. Now inputs are coming, and that inputs will be given to the model, and accordingly the classification will be done. Now the attacker will train the input or modify the input so that it can escape from the model which is applied. So this is the first attack the attacker can try on the ML model. Second, as I said, the data poisoning can happen. And in case of the third one, model inversion happens. Means that they do the reverse engineering. So for example, in case of the federated learning, I said, the hospital sends the trained model to the centralized server for averaging or summarizing, whatever it may be. So now the centralized server can do the reverse engineering, and then they can get the data what is used for the training. And next is the membership inference attack. From the model, they will check that whether this data is used for the training or not. So that also they can try. And sometimes they will steal the model. So when they are going to steal the models, means they are going to steal the parameters that are used. So based on that, they can create the new model, how it will work. And in some cases, we may use the corrupted packages. For example, we download the model or the software, and it is possible that those are already having the malicious content inserted, which is part of the supply chain attack. And then we will be using it. So if you are going to use it, then it will definitely misbehave. For an example, let's say we download various softwares from the multiple sources. And if somebody has modified the data without the knowledge of the software developer, and we all download, and if that is having the malware, because we give all permissions, if that is going to have the malware, then it will infect our system. So this is what the supply chain attack is. And in case of the transfer learning, which I already said, and there is a possibility of the model skewing also. So maybe our data set will be having the bias because it is on one side. So then model will learn accordingly and behave. So attackers will try to do this model skewing also. And the output integrity, let's say the output is produced by the model, and now that output is given for an application. Now there is a possibility in between somebody will come and modify. So the attacker can come and they may hijack the network communication and they will modify and give the output. So we need the integrity. So that should not be attacked by any of the attackers. And also sometimes the model get poisoned. So like by changing the parameters, the model will be poisoned. So one is the data get poisoned, here the model get poisoned. So these are the top 10 security risks involved in the machine learning. So what we can do for controlling some of the attacks, for example, that the first one, that is the input manipulation attack. So we can go for the adversarial training, or we may go for a model which will be implementing multiple concepts. For an example, let's say we go for the switching model. So we have the input, we get the input, and then we have the ML models, and it produces the output. Now, when the input is coming to the models, so we may randomly pick any of the model, because what the attacker will do, they will give the adversarial, let's say they modify the data, considering that there is a model already trained and getting used on the organization. But now here what we are going to do is, we are going to use 3 different models, not only the single model. So what attacker will do? Attacker will train considering one model or modify the data considering one model so that it can escape. So now in case of switching, what happened? Let's say in the first case, the first model will be used for scanning the data or filtering the data. But second time, maybe the third one, and third time, the next one. So it will be various, the models will be switched and getting used. So the attacker cannot predict and try change the input data considering the models present. But if the attackers are lucky, if the data is modified considering this model, and if the same model is used for filtering out or classifying the malwares, then it will escape and the output will be saying as non-malware. So for that reason, we can go for the generalized model. Like here, we can use any one, but in this case, we will be using all the models to be applied for the input, whatever is coming, and then all model will produce the output. Even if any one model classify the input as a malware, then we will classify that as the malware. So like this also we can use, but the problem here is the overhead. So that means we have to apply to all the three models. Sometimes we will be having more models also. So in that case, there will be a overhead, time delay for processing the inputs, and then the input will go for processing. That means to get the actual process. So the delay is an issue in this case. But when it comes into the security, we have to consider the security as an important task, and there will be definitely overhead, but we should try to reduce that overhead, but we should not compromise on the security. So in the conclusion, what I want to say is we have the artificial intelligence and we have the cyber security. AI is required for the cyber security. But the problem is we have to consider the accuracy, because I said the false positive and false negative will always be the problem. So similarly, the artificial intelligence also needs the cyber security, but we have to see the usability, because of cyber security we are going to minimize the data, or we are going to hide much data. Then what's going to happen? Then the model will be trained with the minimal data and the accuracy will not be there. So it is like both has to be there. So then only we can have the efficient as well as the secure environment. So, and one last thing I will tell about the supply chain security. So then I will stop. If any questions, then we can take. In case of the supply chain security, I said that we will download the corrupted packages. So it's not that we download the corrupted packages. That means, let's say the developer has the software and somebody comes and modify that software and keep it in the same repository. And now we are going to download. So when we people download, so all will be infected. So in the normal case, if the attacker want to infect all of us, he has to individually or she has to individually come to all our machine and then infect. But in this case, the attacker can directly modify the repository and we all are going to download that data from the same repository. Then we all are infected. So instead of infecting 100 machines, so only one machine has to be compromised, and then the attacker has to modify and put. Sometimes what happened, there is a building process, the software building process. In the software building process itself, there will be a compromise, and maybe the insider, that means the team members in the development, they may also modify and put the malware included repository, and we download that and we all will get infected. So that's why there are models like the update framework, or we can say that 6-store, or they are having the in toto concept. So that can be used to identify that if there is any supply chain attack happened or there is any violation in the software development with respect to security, not on the performance and the output object. So here I stop. So if any questions, please let me know.
Thank you, sir.
Thank you.
Students, anybody have questions? Right? Okay. Thank you, sir. Good afternoon, everyone. As we come to the close of this insightful and thought-provoking section, I would like to extend my heartfelt thanks to our distinguished speaker, Dr. S. Venkatesan, for taking the time to share his deep expertise and valuable perspective on cyber security and artificial intelligence. Your session has undoubtedly enriched our understanding and sparked curiosity among all of us present here today. I would also like to express our sincere gratitude to Mr. Ketan Kundia, Head of the Department of Computer Engineering, Mr. Satish Ghotpade, IIC Convener, and Mr. Avinash Pawar Sir, Principal of Maharshi Parshuram College of Engineering, Velneshwar, for their unwavering support and encouragement in organizing this webinar. A special thanks to all the faculty members, students, and participants who joined us today and made this session a great success with your presence and enthusiasm. Thank you. Thank you, sir.
Thank you. Shall I leave?
Yes, sir.
Okay, thank you so much.
Okay.